Today's lesson is going to cover two different concepts. One of them is mid-segments of a triangle. So the first thing we're going to talk about is what a mid-segment is. A mid-segment is a line segment, and it connects the midpoint of any two sides of a triangle. So in the diagram that's given to you on the right-hand side, if you look at the line segment DE, it's considered a mid-segment because point D and point E are the mid-segment or the midpoints of each of their sides. Notice that B to D and A to D are marked congruent. That means that D is the midpoint. Notice B to E and E to C are marked congruent, which means that E is the midpoint. The line segment that connects D to E is called a mid-segment because they're both midpoints. In any triangle, there are actually three mid-segments that you can draw. So if I come down on the bottom and I label that point F, if I tell you A to F and F to C are the same, that means that F is a midpoint of that bottom side. So there are two more mid-segments that I could draw in that triangle. One of them would go D to F. The other one would go from E to F. So in any triangle, you have the possibility of drawing three different mid-segments. Now there are a couple of things that are special about a mid-segment. The first thing is it's always parallel to the side that it's crossed from. So for example, side length AC and mid-segment DE are parallel to each other. If I were to extend them, they would never cross. Also, similarly, mid-segment EF would be parallel to line segment AB. If I extended them, they would never cross each other. And very similarly again, if I look at mid-segment DF, it's parallel to side length BC. They would never cross each other. So that's one of the things that is relatable between the side lengths of a triangle and their mid-segments. The other thing that's relatable is that the mid-segment is exactly half the length of the side length it's parallel to. So in other words, if I was again looking at DE, the blue one, and AC, the blue one, if I told you that AC was a length of 10, that would mean that DE is a length of 5. It's exactly half of that third side length. Same thing works the other way around. If I told you that EF was 6, that would mean from B to A would be 12. Okay, so the mid-segment is half the distance of the third side of the triangle. And that's true in any triangle that you can draw a mid-segment in. So moving down, we're just going to look at some problems here. So you're told that DE is the mid-segment, meaning that from D to E connects the midpoint to a midpoint. So the relationship between the mid-segment and the third side of the triangle, the mid-segment is exactly half of that third side, meaning that that x has to be double of that 7, which means that x in this case would be 14. It has to be twice as large as the mid-segment. Also, the mid-segment is half of that length. You can look at it either way. In the next problem, DE is a mid-segment, meaning that D and E are both midpoints. Well, if E is a midpoint, that means the distance from A to E would be the same as the distance from C to E. So knowing that E is a midpoint tells you that that x has to also be 8. The last one over here, if I know that DE is a mid-segment, then I know that it's half the distance of the third side. So x would be half of the 34. Half of 34 gives me an x value of 17. Moving down, we're going to look at a very similar type problem, except we're going to talk about it in terms of algebra this time. So we're going to take each thing and label them. DE is 4x plus 5. DE is right here, 4x plus 5. It's a mid-segment. The reason why I know it's a mid-segment is because in the directions for the problem, it says that D, E, and F are midpoints. So if I connect any of those points, I've formed a mid-segment. The other length given in the problem is GJ, which is this bottom side down here, 3x plus 25. So the way you want to look at this is the mid-segment is exactly half of the third side of the triangle. So DE is half of GJ. That's one way to look at it. You can also look at it as GJ is twice DE. Either way you write the equation, either one of those is going to give you the same value of x. So the first thing I'm going to do is which one is easier. I would say this one because it doesn't deal with a fraction. So I'm just going to set up an equation that says exactly that. GJ, 3x plus 25, is exactly double of 4x plus 5. And so, using mid-segment theorem, all I'm going to do is solve the equation. If I double the right-hand side, I get 8x plus 10. We're going to solve by doing a couple things. We're going to subtract 10 and subtract 3x. So we get 15 equals 5x. And if I divide, I get an x value of 3. Now notice the problem doesn't say to find x, it says find DE. So if I want to find DE, I have to plug my x value back in. DE is represented by 4x plus 5. So 4 times 3, add 5. DE should come out a total of 17. You'll have a problem just like this on your test. So you may want to highlight or star this problem or circle it so that when you review for your test, you come back and rework the problem because there will be one just like this on your test. Moving down, we're going to have a problem that's similar, except they've given you different lengths. So we're going to use the same picture. So I'm going to erase that stuff. And we're going to use the same picture to do the problem. First thing, let's identify what they give us. HJ is this entire side length over here, 8x minus 2. And DF is the mid-segment, 2x plus 11. So again, the relationship is that the mid-segment, DF, is half of the side length, HJ. That's one way to look at it. Or you can look at it as the side length, HJ, is twice as large as DF. Either way is going to give you the same exact answer. They're just different setups. So I'm going to use the same setup we used above, and I'm going to say the side length, 8x minus 2, is twice as large as the mid-segment, 2x plus 11. Solving the problem, we would distribute just like above. 8x minus 2 equals 4x plus 22. We would do a little rearranging. I'm going to add 2 to both sides, subtract 4x from both sides. Doing those two things gives us 4x equals 24. And then I would divide by 4 to get an x value of 6. Now again, notice the problem doesn't say to find x. It says what is hj. So I'm going to plug the x value in for hj, which is the entire side length, 8 times x minus 2. 8 times 6 gives me 48. Subtract 2 gives me 46. If the problem also wanted to know df, you could plug the x value in, or you could just know that df is a mid-segment, which means it's half of hj. That'd be 23. So either way you look at it, which should give you the same answer. The last one down here that we're going to look at, I'm going to erase everything on the picture again. So we're going to use the same picture. And let's label what they're given. First thing, EF, is right here. It's a mid-segment. It is 5x minus 2. And the last thing is DH that I'm given, which is this piece here. And that is 3x plus 8. So what you have to do here is you have to use a little common sense. And what you have to know is, if the mid-segment is half of the total side length, that means that one piece of the side length should be equal to the mid-segment. So all I'm going to do in this case is know that DH and EF have to be equal to each other. So all I'm going to do is set them equal. 5x minus 2 equals 3x plus 8. Simple equation to solve. First, add 2, subtract 3x. So you get 2x equals 10. Dividing gives me an x value of 5. Again, notice the problem doesn't say to find x. It says what is hg. So all I'm going to do is identify on the picture, hg is the whole side length here. So what we need to do is we need to find a part of it and then just double it, because whatever this piece up here is the same as the piece on the bottom. The reason why I know that is because in the directions it says D is a midpoint. So let's plug the x value into DH. So 3 times 5, add 8. That gives me DH as 23. But that's only a piece of HG. I have to double that, and I get HG to be a total of 46. Again, you'll have a couple of problems on your test that are very similar to these three. So if I was you, I would circle them or star them or highlight them so that and make note of it, so that you come back to these types of problems and you rework a few examples in preparation for your test. On the bottom, we've got some multiple choice problems. So the first thing is, in the diagram, it says that UV and WU are mid-segments, meaning that if this is 5, this piece up here would be double, which is 10. If WU is a mid-segment, this third side is 8, which means this piece would be half of that, which is 4. And in the problem, it says, find the length of WX. Well, if WX is all the way across 10, W is the midpoint, meaning that each side of this would have to be 5. So there's your answer choice, letter A. In the second part, it says find WU. WU is here. We already said that if this whole third length is 8, that means that this WU has to be half of that. We already labeled it as 4. So your letter choice D, 4. If you have any questions on the front, make sure that you make note of those problems so that next class, the first thing I am going to ask for is questions from this so that you can ask me specifically, Mr. E, number 14 didn't make any sense to me. Mr. E, I don't understand why you're saying that HG was double in this previous problem, and I wanted to answer 23 instead of 46. Why did you answer 46? So just make sure you make note of that so that I can see what questions you have. On the back, we have our second concept, which is called a perpendicular bisector. Now, perpendicular and bisector are two words that we've talked about this year. Perpendicular meaning meet at a right angle, and bisect meaning cut in half. So in this picture over here on the right side, we would say that the blue line that I'm highlighting in purple now is a perpendicular bisector for two reasons. It bisects the segment, and it hits at a right angle. So that's why it's called a perpendicular bisector. So the theorem behind this says that any point on the endpoints, of your segment are the same distance from point C. So if I draw a segment from A to C, it should be the same length as the segment from B to C. So what I've actually formed here is an isosceles triangle. So any point on your perpendicular bisector is the same distance from your endpoints. So if I put another point down here and called it point D, we could actually say that the distance from A to D is the same as the distance from B to D. So I could move point D anywhere on that purple line, and the distance from A to D and B to D would be the same exact distance. So you're forming isosceles triangles all over the place in pictures like this. So in these three problems down here, what we need to notice is BD goes down the center, it bisects, and it's perpendicular, which means that the distance from A to B is the same as the distance from B to C. So all I have to do is set the two pieces equal and solve for x. So the first thing I'm going to do here is subtract 5x. And if we divide by -3, we get an x value of 2. Now notice the directions don't say find x, they say find the length of AB. So once I've found x, I've got to plug the x in. Well, simply, 2 times 2 is just going to give you AB as a value of 4. Just make sure you're reading the directions so you know what question you're answering. Again, this problem is very similar. BD is a perpendicular bisector because it cuts the segment in half and it hits at a right angle. So that means that the distance from A to B is the same as the distance from C to B. All I have to do is set the two pieces equal and solve for x. It's going to require we do 2 steps. Add 16, subtract 3x. So we get 4x equals 24. And then dividing gives me an x value of 6. Just like the last problem, the value of x is not the end of the problem. We have to plug the x in. 3 times 6, add 8. 3 times 6 is 18. Add 8 to that, and AB comes out as 26. Number 3 is done just like the two previous. BD is a perpendicular bisector. It cuts the segment in half, and it meets at a right angle. Meaning that there are 2 sets of congruent line segments up here. C to B and A to B, and also D to C and D to A. Now, if you notice, the blue segments are the only ones that are labeled with anything. Therefore, those are the segments I'm obviously going to set equal to each other. But keep in mind, in that picture, there actually are 2 sets of congruent segments. D to C and D to A are also a set of congruent segments. So if they were labeled with variables, you'd also be able to set up an equation with those ones too. So solving the equation that I wrote, we're going to subtract 6x and add 9. That result's going to give me 5x equals 20. And then dividing by 5 gives me an x value of 4. Plugging in, we want to plug in here for AB. 11 times 4, subtract 9. 4 and 11 gives me 44. Subtract 9, and AB comes out as 35. Moving down, we have a few more problems. So in this problem, notice we've got x's and y's. And what we want to notice about this is that I've got some important facts. Number 1, my triangle up here is isosceles because I've got 2 tick marks here. So if my 2 line segments here are isosceles triangle, that means that I can set 10y minus 4 and 7y plus 8 equal to each other to solve. And again, the reason why is that is an isosceles triangle. So what we can do then is we can add 4 and subtract 7y. So we get 3y equals 12. Divide by 3, y comes out a value of 4. The next thing I would want to tackle is I would want to look at this as if I continued to extend this and I went from E to G, would that purple line be a perpendicular bisector? Now the reason why I know it's perpendicular is because it hits at a right angle. Now the reason why I know that it's a bisector, since these 2 pieces are the same, that means the distance from G to F and G to D are the same. So using the perpendicular bisector theorem, I know that that segment, that purple segment, has to bisect because G to F and G to D wouldn't be congruent if that wasn't true. So what that then means is these bottom segments from F to E and D to E have to be congruent. That's perpendicular bisector theorem. So I'm going to set those pieces, 9x minus 1 and 7x plus 9 equal to each other. And we're going to solve for x. Adding 1, subtracting 7x. We get an equation of 2x equals 10. Dividing by 2 gives me an x value of 5. Now, once I've figured out the x and y values, now I can come over to the problems and actually answer what are all of these lengths. EF is labeled with 7x plus 9, so we're going to plug x in. 7 times 5, add 9. 7 and 5 is 35. Add 9, you get 44. There's the first one. FG is labeled with 7y plus 8. So in this one, I'm going to plug the y value in. 7 times 4, add 8. 7 and 4 is 28. Add 8, 36. The last one is FH. And if we look up here, FH is labeled with 3x plus 4y. So I'm plugging in both the x and the y into this one. So 3 times 5 and 4 times 4. 3 and 5 is 15. 4 and 4 is 16. Together, 31. So when you see a problem like this, before even paying attention to what 7, 9, and 11 are asking, it may be beneficial just to look at the picture and find x and y first. Last problem. We know that the perpendicular bisectors of a side length, they're the dashed ones, they not only meet this at a right angle, meet this at a right angle, meet this down here at a right angle, they also bisect the side lengths. So DA and DB have to be the same. That's what it means to bisect. We know that BE and CE are the same. That's what it means to bisect. We know that AF and CF are the same. That's what it means to bisect. Now, the other thing that it means is, since I have a perpendicular bisector, that means that any segments that connect to the perpendicular bisector have to be the same. Any segments that connect to the perpendicular bisector have to be the same. So all of those yellowish lines I just drew, they all have to be the exact same. They all have to be 25. Because we learned above that any segments that are connected to the perpendicular bisector have to be the exact length because they're the same distance from the endpoints of the segment. So that means I've got all of the lengths possible labeled on my picture, so we just have to copy down the ones that are asked for. BD, labeled in purple over there, is just 20. CF, labeled in this grayish color, has to be 24. BG is one of those yellow ones, yellowish colored ones. That's 25. And the last one is AC. AC is along the entire bottom, which 24 and 24 is just 48. So again, in a picture like that, it may be beneficial just to label every side length you have information about and then go to see what is it actually asking me to figure out the length of. Because most of the time, you will have already found the lengths you're being asked for. Make note, please, of any questions you have so that when I ask for questions, you have them ready to ask in class, and we can rework and re-explain any problems that you had issue with.